Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE exam practice with the Batty Boffin, and here we have got Bathilda the cat. She has been very naughty this week and she's had to go to the vet, and the vet has given her the cone of shame. Oh yes. Now, in order to alleviate her mind and the sufferings of her cone of shame, Bathilda has decided to analyse her cone, and here it is drawn out. Okay, it's actually known as the frustum of a cone, which means it's got the bottom bit chopped off. A bit like if you have one of those ice cream cornetto things and you bite the bottom off and then all the ice cream comes out the bottom. It's like that. Okay, the circumference at the top is 60 centimetres. The circumference at the bottom is 20 centimetres, and the perpendicular height between those two is 7 centimetres. So for part A of this, I would like to know, please, how tall would be the entire cone if it were all there? Okay, that's part A. Off you go. Right, this question here we can actually do with similar triangles. You can regard a cone as like a 3D triangle. Okay, this is 3 times this. Okay, the 60 is 3 times the 30, which means that if we put the rest of that cone on, the rest of that cone there, okay, the whole big cone, having a base of 60, would be 3 times the little cone that's not there, having a base of 20. Okay, since circumference is a linear measurement, that gives us the scale factor. I know it goes round in a curve, but that doesn't matter. Any linears all apply to the same scale factor. So if between the small cone and the big cone is a scale factor of 3, then the heights will also be a scale factor of 3, which means that that little one there has a height 1/3 of the whole thing. So that is 1/3 of the entire thing. If that is 1/3, then that must be 2/3. And since 7 is 2/3, it means that that bit must be 3.5, which gives us a total height, ooh, not a very good pen there, a total height of 10.5 centimetres. It's way too hot in here and all my pens keep running out. 10.5 centimetres, and we're doing that one by similar triangles. Okay, I'm going to wipe down the board, I'm going to come back up and we'll do part B in a minute. Now, I've drawn here a picture of what our cone looks like on the inside. So we've got a radius there, which I've drawn here. That's the centre of the imaginary circle that's in the middle at the top there. So that's my thing. There we have the perpendicular height, which I've marked in as 7. Then we've got, that's the base radius across there. Okay, which is here. And then the dotty bit is the rest of that cone that would be there if it were there. Okay. So what you've got to do on here is please work out L, which is the slant height of the cone if it were all there. Okay, so we want the slant height of the cone if all the cone were there. Okay, off you go. Right, in order to do this one, we're going to do a bit of Pythagoras. We've got a right angled triangle here. That bit is 7. We know that the whole bit, because we worked it out in part A, is 10.5. And we need that bit in order to find L. Now that bit at the top there is the radius of the circle, and we can find that quite easily because we know that circumference equals 2 pi r. So grabbing a quick calculator, I have a pink one, any colour will do, and we're going to do, we've got circumference equals 60, so 60 over 2 pi will equal r. R equals 9.55 centimetres. Okay, so that bit there is 9.55. With that in mind, we can work out the value of L. I'm going to use the full value on my calculator here. I'm going to square it, and then I'm going to add on 10.5 squared. I'm assuming you know Pythagoras, okay? If you're not sure what I'm doing here about finding the longest side of a right angled triangle, check out some of the other Batty Boffin videos, but I'm just going to whiz through and assume you know what you're doing here. I'm doing 9.55 squared plus 10.5 squared equals that square root of the answer, and we get 14 to 1 dp, we get 14.2. 14.2 centimetres. There. Did you get that? I hope so. Now for part 3, part C on here, Bathilda, much enamoured with her cone of shame, decides she'd like to make one for herself. She's actually going to make one out of some quite nice fabric because, quite frankly, this is kind of grey plastic and it's boring. So she decides she's going to make one out of something a little more interesting so that she can at least decorate up her cone of shame. And she works out what shape she needs. In order to make a cone, she needs a shape kind of like that. And then these two edges join together to make the cone. Okay? And all we want to know on here is what angle does she need to cut out? Okay, what is that angle? Theta, that's a little mini theta there. Okay, so it's this kind of windscreen wiper shape she needs to cut out in order to make the cone. What is the angle at the centre? Okay, so part C, off you go. Right, here is Bathilda's redesigned cone of shame, decorated rather artistically with purple swirls. So it kind of makes me think of Cadbury's somehow. Must go eat chocolate. What we've got here is the part of a circle, this kind of windscreen wiper shape here, or like part of a polo mint if you like. The outer arc here is 60 centimetres because that's forming the outer edge of the cone up there. And we've got an inner one here of 20 for that arc, which becomes that circumference around there. And the important one is that this long diagonal that we calculated in part B is actually the radius of the shape that we're cutting. Okay, hope you got that bit. Using that 14.2, we can do the calculation for the arc of a circle. The arc of a circle is 2 pi r, which in our case is 14.2. 2 pi r will give us the whole circumference of this circle multiplied by whatever fraction of it we want. I'm using theta, you could use a, it doesn't matter. Theta over 360. And in our case that is going to equal 60 for the full arc on the outside there. Okay, so just doing a quick bit of rearranging here. What I'm going to do is multiply both sides by 360 and then keep dividing by lots of things till I end up with theta left on the end. So I'm going to start off with 60 and we get an answer of theta, ta-da, 242.1 if you want to go to 1 dp there, 242.1 degrees for theta. Right, hope you got that. If you didn't check out some of the other Batty boffin videos where I'll go through this rather more slowly, particularly stuff like that. If you weren't sure what I was doing there, watch out, I did that very quickly on here. Okay, other Batty boffin videos will be covering lots of other things. You will see Bathilda featuring in, I think, pretty much all of them, so keep a lookout for her, and I'll see you next time, Batty fans. Bye for now.